Okay, so here we're on the third installment of this exercise. And today we're going to be doing assess and compare of the interpolation results, which consists of open and explore the cross-validation window. And then we're going to view the line chart and histograms for summer 2015. And then we're going to interpolate and average dissolved oxygen levels from the summer 2015. And then we're going to compare summer 2014 to summer 2015 using cross-validation. And that's going to be it for today. Okay, that's enough. That's enough for today. So this is supposed to take 20 minutes. So far we've been doing that pretty well. So let's see if we can keep on going. Okay, so here we are with where we ended with the Chesapeake Water Quality Project. Let's see. So we're going to start at the beginning. Is this in the contents pane? So this is our contents pane. We're going to right-click on kernel interpolation. And we're going to choose cross-validation. There we are. Let's see. On the right side of the cross-validation window, we're going to click the table tab. So you can see all the different measurements that have gone into this. Okay. Our next instruction is click the error column tile to sort from lowest to highest. So we're going to click to sort from lowest to highest. Or we can click the error to go from highest to lowest. So okay, and the way that we're going to do that is we're going to expand our window here so you can see our error column. There it is. Okay, and our standard error. So we can click on here. Okay, and there we go from lowest to highest. Click again and we go from highest to lowest. So not unlike any other database. Let's see. The highest cross-validation is about 3.03. That's correct. Let's see. We're going to click the first row. We're going to click the first row to choose a point with the highest validation error. And let's see. So if we notice, we can click on predicted up here. And there's our highlighted point right down here. Do you see it? We could probably do another one. There you go. So the point being that when you highlight a data point on here, the data point is highlighted on your chart. Okay. All right. We go to error. There it is, way up here. Okay. Let's see. We're going to look at the summary. When we click on the summary, we can see the mean, we can see the root mean squared, the mean standardized, average standard error. So here's all your statistics right here. Okay. So a lot of information there. Your author doesn't address it, but there's a distribution. I mean, there's just, point being is that you can analyze it statistically very nicely. Okay, we're going to close the table. And now we're going to go to the next point of this, which is view the line chart and histogram for summer 2015. Let's see. Okay. So this is where watching this video is face off, because it gives you an instruction and they're not easy to find. What it tells you is, if necessary, open the filter samples for summer 2014 and summer 2015 task. How do you do that? Well, here on the geoprocessing, under geoprocessing, we're going to click on catalog, and then we're going to open up tasks, and there's a filter samples for summer 2014 and 2015. Okay. Okay. Now we're going to, it says double click apply summer 2015. So we're going to double click on it. And we're going to click run. Okay. The measurements that were taken between June 15, 2015 and September 15, 2015 at depths greater than 5 meters are selected. Click on finish. Okay. In the contents pane, click list by drawing order. So down here at the bottom of the tabs, we have tabs. Click on contents, and then we're going to click on list by drawing order. And what that means is that we have to select this first one here. So we have all these tabs up here under this pane. The first one is list by drawing order, list by data source, list by selection, list by editing, list by snapping, list by labeling, list by perspective imagery. So we got to make sure that we're in the first one. Okay. And then we're going to double click on distributions of major value. So right here, we're going to double click on it. And our chart that we came up with last time comes up. Okay. We're instructed to click selection to display only selected samples from summer 2015. So here's, okay. That looks pretty good. Let's see. If necessary, turn on median and standard deviation. So here's the chart properties pane over here. We're instructed to turn on median and standard deviation. So now we know where the median is in purple. And we can see where the standard deviation is in brown. Very, very cool. In the contents pane, double click change in mean value over sample date to reopen the line chart. So we're going to open this other one, the line chart that we did before. We do that by double clicking. Apparently I don't double click fast enough. There we go. In the chart properties pane, as over here, for time binning option, change the interval size to 5 days. So time binning options, we can change this to 5 days. Two, three, four, 5. Look at that. Is that nice? Okay. What else? If necessary, click selection to display only selected samples from summer 2015. So I click on selection. There it is. That's looking good. Okay. Now it says close chart properties pane as well as both charts. So there goes the chart property pane, and there goes 1, 2 charts. Okay. Let's see. I'm trying to figure out if we're already at the next step. I don't think we are, not yet. Let's see. Next step here says interpolate average dissolved oxygen levels in 2015. We're pretty close, but we're not done. Okay, it says on the ribbon, click the analysis tab. So we're going to click on the analysis tab. There it is. In the geoprocessing group, click tools. So we're going to click on tools. Okay. The geoprocessing pane opens. And the geoprocessing pane search for kernel. So we're going to click right here. We're going to look for kernel, K-E-R-N-E-L. The search returns several possible geoprocessing tools that implement or contain the search term. Click kernel interpolation with barriers. Kernel interpolation with barriers. Okay, there we are. The kernel interpolation with barriers geoprocessing tool opens in the geoprocessing pane. For input features, we're going to choose dissolved oxygen. That doesn't seem like a surprise. For Z value, choose major value. Major value. For output geostatistical layer, type summer 2015. I'm lazy, so I'm going to copy and paste. Copy and paste. Boom. This parameter specifies the resulting geostatistical layer name. For input absolute barrier features, choose Bay. So input absolute barrier features, we're going to put the Bay. Since this parameter specifies that the Bay layer will be used as a barrier in the interpolation, this will allow the tool to use water distances. Accept the remaining default values. Let's see. By leaving the bandwidth, let's take a look at the bandwidth. By leaving the bandwidth parameter empty, the tool will determine the value of the bandwidth that results in the smallest possible root mean square cross-validation error. This is also how Geostatistical Wizard determines the optimal bandwidth in the previous lesson. Okay, so we're going to click Run. Boo. Okay, the tool executes a layer named Summer 2015. It's added to the Chesapeake Bay dissolved O2 map. Okay. Summer 2015. Which is right there. This layer represents the predicted average dissolved oxygen level across Chesapeake Bay from the summer of 2015. In the contents pane, turn off the dissolved O2 layer. So we got to scroll this back down here. There's the dissolved O2 layer. We're going to turn that off. Okay. This layer represents a predicted average dissolved oxygen level across the Chesapeake Bay for the summer of 2015. On the ribbon, click Appearance tab. In the effect group, click Swipe. We click Swipe. And if you guys don't remember, this allows us to look at that. Isn't that sweet? We can move it up and down, and we can contrast. Let's see. I think we're doing 2014 and 2015. Is that awesome? So in other words, you can see what's happening in one summer versus the other. This is very cool. Okay. As with summer 2014, the highest average dissolved oxygen levels in summer 2015 are at the tips and inlets of the and near the Atlantic Ocean in the southern part of the bay. The lowest dissolved oxygen levels are again in the middle and upper parts of the bay. So that seems to be a constant, doesn't it? On the ribbon, click the Map tab. Map. In the Navigate group, click Explore. Click and deactivate the swipe tool. And we got one last thing to do. The last thing is compare summer 2014 to summer 2015 using cross-validation. Next, you'll view the cross-validation window for the layer created in the previous section and compare the number and graphs to the map from the summer 2014. In the contents pane, double-click the kernel interpolation layer. So here's our kernel interpolation layer. We're going to double click on it. Okay. The layer properties window opens. In the general tab for name, delete kernel interpolation and type summer 2014. So I'm just going to copy and paste because I'm a lazy scientist. There it is. Renaming the layers summer 2014 will help you differentiate and compare results from 2014 and 2015. Click OK. In the contents pane, right-click summer 2014. Okay, we're going to right-click summer 2014, and we're going to choose cross-validation. There it is. The cross-validation window for the dissolved oxygen levels of summer 2014 opens. In the contents pane, right-click summer 2015. Right-click summer 2015 and choose cross-validation. Okay. The cross-validation window for the dissolved oxygen levels for summer 2015 opens. Compare the root mean square and mean values for both summers. shoe. So if you carefully click on it, you can move the charts independently of each other. There we are. And they're telling us to do what? Compare the root mean square. So root mean square for 2015 is 1.00. And for 2014 is 1.11. Okay. The mean or the average. So the mean .02 over here, 0.03 over here. Okay. Okay. And then let's see, we have a count. And then he's so the author made a little graph there that's summary, summer 2014, 2015, and brings all this data into account. So the root mean square dropped from 1.117 there it is, 1.117 to 1.002. This indicates that the predictions from cross-validation were about 10% more accurate in summer 2015 than summer 2014. This is likely because summer 2015 had about 10% more data, 85 points, versus 78 points for summer 2014. The mean value changed from 0.045 in summer 2014 that doesn't seem to be agreeing with us, huh? He's calling it 0.045 to 0.021. The second number is correct, but the first one is not. So it's supposed to be 0.035 to 0.021. Okay. The value, this value should be as close to 0 as possible. So summer 2015 has slightly lower bias than summer 2014, though both summers had low levels of bias. In the graphical diagnostics, click the predicted tab for both summer 2014 and 2015. So we're right there. Okay. Okay, the blue regression line for summer 2015 appears to fall closer to the gray reference line than the region line for the summer 2014. So these two are closer together than these two. In the graphical diagnostics, click the error tab for both of them. So we're going to click on error, and we're going to click on error. Okay. The graphs on error tab for summer 2014 and summer 2015 appear to be nearly identical. You may recall that ideally the blue regression line will be flat. A regression line that is decreasing, as in both summer 2014 and 2015, indicates that the model is smoothing the data and under predicting large values and over predicting small ones. Okay. Let's see. Compare the slopes of the regression function. Okay. Here's a regression function here and here. The regression function shows that the slope of the blue regression line is slightly more negative in 2014. So it's minus 0.67 versus minus 0.58 in 2014 than in 2015. This indicates that there is slightly more smoothing in summer 2014 than in 2015. Thus, you can conclude that the interpolation for summer 2015 is less likely than the interpolation of summer 2014 to incorrectly predict safe levels of dissolved oxygen in location where the actual levels are unhealthy or dangerous. However, neither year shows severe levels of smoothing. We're going to close both of them. Done and done. It says save the project. Remember, this is the last of the third part, so we're going to go project. We're going to go save as, and we're going to save it as Chesapeake Water Quality 3. III. That'll be the third map, and we've got one left. Okay? So that's it for now. We got one more tomorrow, and then we're done with the project. That's not awesome? Okay. Thank you very much, all of you.